So we're going to look at question number 22 from 2.22. Yes. So question number 22 is using the law of syllogism to write a new conditional statement that follows from the pair of true statements, if possible. So with the law of syllogism, a hypothesis and conclusion had to match up. So if we look at this here, well, we have an if A equals 3, and then we also have a then A equals 3. So we do have an if and then that match up. So we can use this property, and all we have to do is grab the new if and then. So if 1/2 A equals 1/2 then, and that's all we'd have to do for this here. Any other questions on this here? Any other questions on any of the homework assignments? So I had this question up while y'all were coming in. How can you prove a mathematical statement? By a proof. A proof is a logical argument that uses deductive reasoning to show that a statement is true. And that's really what we're going to start doing today. Is we're going to be using these proofs, these deductive statements, to prove that things work or that statements are true. And so the first one we're looking at is this one here. Write the reasons for each step. We want to write the reasons for each step of this here. Now, with anything, we always start with what is given. They told us that AC is equal to AB plus AB. That's just what they told us. They told us that it's true, so that is what we start with. Now, what they want us to prove, so given, what we're starting with. And what they want us to prove is that AB is equal to BC, what we want to prove. Because we always start with the given and end with what we want to prove, or what we want to show. So we start off with the fact that AC is equal to AB plus AB. That was given to us. Now let's look at the next statement. AB plus BC is equal to AC. So we're saying AB plus BC is equal to AC. So we have the two parts of the line added together give me the whole. Is there a postulate that we know that makes this true, that works for this here? What are we doing? Addition. The segment addition postulate. The segment addition postulate states that I can take, if there's a point A, B, and C on the line, and their point B is between A and C, then AB plus BC is equal to AC. The two parts equal the whole. So AB plus AB, well, that we do have up here. And we also have that AB plus BC. Well, that's right there, yes? This here is our property of equality. Because really we're saying that AC is equal to AB plus AB. A is equal to B. Then we also have that AB plus BC is equal to AC. C is equal to B. So A is equal to C. Because since AC is equal to AB plus AB, and AB plus BC is equal to AC, these are the same, so it means that these two must be equal. So what we've been able to show, and what they've shown so far, is that AB plus AB is equal to AB plus BC. Well, AB, any of these here are just lengths. And we know it's a length because there's not a line segment above it. We're talking about just AB, not line segment AB or line segment BC. So these are just measures. Well, do I have an AB in common on both sides? Well, yeah. So what can we do? We could subtract it from both sides. We can subtract AB from both sides, which would simplify down, which would be our of and that's it. And that right there is the entire proof. Any questions on this here? Are we ready for the next one? Let's look at this here. 6 steps of a proof are shown. Complete the statements and correspond to each reason. So we're filling this out. We're filling in what's missing. Now with any of these here, we always start with what? The given. Now what did they tell us the given is? Measure of angle 1 is equal to the measure of angle 3. So our first statement should be the measure of angle 1 is equal to the measure of angle 3, because that is the given information. That is what they told us. And our last step, or last statement, should be what? Statement number 6 should be what? What we're trying to what? Prove. So measure of angle EBA is equal to the measure of angle CBD. Measure of angle EBA is equal to the measure of angle CBD. Okay. Now, if I need to know that they are equal, we need to define what they are, what EBC and EBA and CBD are. Because if we can describe what they are and make them or show that they are the same, that their properties or components are the same, then we can say that they are equal. Now, they start off with saying that EBA is equal to the measure of angle 2 plus the measure of angle 3. Well, yes, that is true. We can see that it is the angle addition postulate. Is how we go from step 1 to step 2. Now, from step 2 to step 3, they say the substitution property of equality is, what do we know? The measure of angle 1 is equal to the measure of angle 3. So here it says 2 plus 3, but I can replace 3 with 1. Now, the next step is not something I'm not going to normally make you do, but it is something that they have put up here, the commutative property of addition. Really what this is saying, that the measure of angle 1 plus the measure of angle 2, that we can switch the order. We're not going to be this nitpicky in here. I'm not going to require you to be as precise as this here, because really what they're wanting to do is show that they are in the same order. And we know that the measure of angle 1 plus the measure of angle 2 is going to be the same as the measure of angle 2 plus the measure of angle 1. Okay, so we've made it up to this point here, yes? So we've talked all about EBA, yes? What are we missing? CBD. Have I said anything up to step 4 about CBD? So if I don't mention it in step 5, is there any way that I could say that they're equal? Right, and it gives us a hint, angle addition postulate, yes? What is CBD? 1 plus 2. So this would be equal to the measure of angle CBD. So now we can say that they are equal by the transitive property of equality, because EBA equals the two angles added together. The two angles added together equals CBD. We do have something in common in both, so it means the two angles have to be equal. And that is it. Questions on this here? So, we're going to write this proof. Given measure of angle 1 is equal to the measure of angle 3, prove that the measure of angle DBA is equal to the measure of angle EBC. Well, what can we start out with? Well, the given information. Because that's what we're always going to start with. And what are we going to finish with? What we're trying to prove. What we're trying to prove. That these two angles here are equal. Now, with a lot of these proofs, there's more than one way to go at them, because there's more than one way we can actually state the steps out and work them out. Now, for the test, I will have it pretty much laid out for you. I'm not going to have you do a lot of these proofs all the way out on your own. You are going to be filling in the blanks. Now, on the homework, you're going to have to do a little bit more than that. You'll have to fill some of them out. So I will be looking through and making sure that they do follow or work well. So when we look at this here, so we know 1 and 3 are equal, yes? And we want to show that B, or DBA and EBC are the same, yes? So I need to define DBA and EBC in some way that I can show equality, yes? So it might be good to actually define one of the angles in parts, especially with angles 1 and 3. Because if they gave it to me, it means I'm probably going to use it. So our second statement is just defining one of these two angles, DBA, is equal to the measure of angle 3 plus the measure of angle 2. Because I needed to find one of the angles in one a way or in the other. Now, did I have to use DBA? Well, no, I could have used EBC. We could have used either one first. Well, why can I say that DBA is equal to the measure of angle, or the measure of angle DBA is equal to the measure of angle 3 plus the measure of angle 2? What postulate says I can do this? Angle addition postulate. The angle addition postulate. Because the angle addition postulate says this: if there exists an angle AB, or an angle ABC, and a point D lies in the interior of the angle, then ABD plus DBC is equal to ABC. The two parts equal the whole. Well, so we have 3 and 2, yes? And we know that we want to make, so this is DBA. We want to make it the same as EBC, yes? What is EBC? 2 and 1. Well, what do I know about 1 and 3? They're equal, so really, I can substitute the substitution property of equality. Angle 1 in for angle 3 because they are the same. Well, as we can see here, there's only one step left. Yes? What have we not done anything with? EBC. So step 4 should include EBC, which again will be our angle addition postulate. And reason number 5 is going to be the transitive property of equality. Because we showed one of the angles is equal to the measure of angle 1 plus the measure of angle 2. And the other angle we wanted to show that's equal is equal to the measure of angle 1 plus the measure of angle 2. So those two angles are congruent to each other. Since these two match, it means that these two will be equal as well. Questions on this here? Questions on anything we've done so far? Okay. 6 steps to a 2-column proof are shown. Copy and complete the proof. Given T is the midpoint of SU. Prove X equals 5. Well, they put the given in what we're trying to prove already in the statements. Because they told us T is the midpoint of SU. And that would be our what? Given. That is our given information. Now, if T is a midpoint, what do we know about midpoints? They do what? Right, they bisect a line into 2 what? Segments that are congruent. Because the definition of a midpoint is a midpoint if it divides the line into 2 congruent segments. It is a point that divides the line into 2 congruent segments. So following that T is the midpoint, we can say that line segment ST is congruent to line segment TU. Well, why do we know it cuts it into 2 congruent segments? Because of the definition of a midpoint. That's what a midpoint is. Well, if 2 segments are congruent, it means that their lengths are the same. So I can say that the length of ST is equal to the length of TU. Well, why do we know that? The definition of congruent segments, that's what it means to be congruent. Yes? So really these first 3 statements, well, the first one was given to us, yes? Because it's a midpoint, it means that we have 2 congruent segments. That's just definition of midpoint. Since they are congruent, it means that they are equal. That's just definition of what congruent means. Now, this here is going to be our substitution property of equality. Because what did we do? ST is what? 7x. TU is 3x plus 20. We substituted those values in. We substituted those values into the problem. So what is it? So any questions on 1 through 4, or anything we've done up to this point for this problem? Now what would we do next? Subtract what? Why would we subtract 3x? Because we're trying to get x on the same side, yes? So if I subtract 3x from both sides, well, 3x and 3x would cancel, yes? 7x minus 3x would be 4x is equal to 20. And hey, they have it already there, subtraction property of equality. Okay. Yes. Division property of equality, because again, to get x equals 5, we have to divide both sides by 4. If we divide both sides by 4, then we will get x equals 5. This 20 divided by 4 is 5. Yes. Any questions on this here? Now these here aren't filled in, but you can fill them in if you want, or at least with the example for each. Segment congruency in reflexive, symmetric, and transitive. Well, reflexive, for any segment AB, AB is congruent to AB. It's congruent to itself. When we looked at it on Friday, the reflexive property of equality said A is equal to A, it's equal to itself, yes? Is that any different than what here? For reflexive property of segment congruency? Well, no, that's the exact same thing, isn't it? How about the reflexive property of angle congruency? For any angle A, A is congruent to A. Angle A is congruent to A. Well, it's the same thing, isn't it? It's just talking about what? Angles and segments. Symmetric. If AB, line segment AB is congruent to line segment CD, then line segment CD is congruent to line segment AB. They are congruent to each other. Symmetric for angles. If angle A is equal to angle B, then angle B is equal or congruent to angle A. Sorry, let me try that again. If angle A is congruent to angle B, then angle B is congruent to angle A. The reflexive property of angle congruency still holds true. Just like with our reflexive or symmetric property of equality. A is equal to B, so B is equal to A. We can flip it. And lastly, transitive, the transitive property of segment congruency. If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then line segment AB is congruent to line segment EF. Same thing's true for angles. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Questions on this here? Name the property that illustrates, that the statement illustrates. If angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. Okay? Of because what are we talking about here? We're talking about angles. Transitive property of angle congruency. But y'all can see that it is transitive because angle T is congruent to angle V, and angle V is congruent to angle R, then T is congruent to R. We know that's transitive, yes? But is there an equal sign anywhere in there? Well, no. I mean, they're all congruency. We're talking about congruent, yes? So that kind of tells us. Well, it says angle T, angle V, angle V, angle R. We're talking about angles. So if we can at least see that it's transitive, well, then the rest is kind of told to us because angles and congruencies. Now, if we look at B, property of segment congruency. Symmetric property of angle congruency. And you do have that in your reference sheet, those three listed out. Any questions on this here? All right, let's look at the next one. So when we look at this sphere, write a two-column proof from the symmetric property of segment congruency. Given LM is congruent to NP. Well, that's what we would start out with. And it's our given. What are we wanting to prove? The line segment NP is congruent to line segment LM. So they first told us that LM is congruent to NP, yes? Well, what do we know about two things that are congruent? They are. So LM is equal to NP. And why can we say that? Which would be our definition of congruent segments, because if two segments are congruent, it means their measures are equal. And since we're talking about measures, we don't include the line segment above LM or NP. So again, we have one last step, yes? What's the difference between 2 and 3, how it's written? NP goes first, yes? Well, I can flip them, yes? And this is going to be equality, but what property says that I can flip it? You're on the right track. Property of, as we're talking about two things being equal. Anybody know what our reason for number 4 is going to be? When we say that line segment NP is congruent to line segment LM? Why could I go from reason or 1 to 2? So how can I go from 3 to 4? Yeah. Because if 2 segments are congruent, it means their measures are equal. If 2 line segments measures are equal, it means that they are congruent. Questions on this here? Get ready for the next one. Prove this property of midpoint if you know that M is the midpoint of AB. Prove that AB is 2 times AM, and AM is 1/2 of AB. So what are we going to start off with? The given, which is M is the midpoint of AB. And that is our given. Now they wanted us to prove that AB is equal to 2 times AM, or AM is equal to 1/2 of AB. Which one of those two do you think we'll do last? Do you think we'll do AB equals 2AM last, or AM equals 1/2 AB? AM equals 1/2 AB would go last because really we can get it from 2AM equals AB. Bless you. Because if we can at least say that AB is equal to 2 times AM, well, we can divide both sides by 2 and get that AM is equal to 1/2 of AB. Okay. Now let's fill in the rest. So they started off with telling us M is the midpoint of AB. Well, what does a midpoint tell us? It cuts it into 2 congruent. So what would the 2 congruent segments be? AM and MB are congruent. Well, that's just about the definition of a midpoint. That's what a midpoint is. Well, if the 2 segments are congruent, it means that they are what? That's just definition of congruent segments. Because really, if we're going to talk about this, and we have an equation, because they told us AB equals 2AM, yes? I'm going to have to talk about their actual measures. Because if we're just talking about the line segments being congruent, I don't need the measures. But because they say 2AM equals AB, I've got to bring it all the way down to the actual measure. Okay? So we've talked about that so far. Is there any further that I can take AM and MB? Is there any more that I can do with AM equals MB? No, that's about as far as it can go, yes? But I still need to get to the fact that 2AM equals AB, yes? What have I not said anything about yet? Because have we talked about AM? Have we talked about, so we've talked about MB. Have we said anything about AB? So what do we need? We need a statement about AB. Well, what do we know about AB? Is the whole thing, yes? Is what? Well, we have that. That's where we want to go, yes? Well, I can't just immediately jump to it. But what do we know about A to B? The whole line. Do what? B? Mm-hmm. Yep. So I can say that AM plus MB is equal to AB. That's a segment addition postulate. Because I do know that's for certain. Okay, so we've defined AB, yes? Now there is a step in between that we need to do. Now we are trying to go from AM plus MB equals AB to 2AM equals AB, yes? So do I really need MB in this statement? No, because that wouldn't be too helpful. But what do I know about AM and MB? They're what? They're equal, yes? So can I replace MB with AM? Well, yes. And we could say that AM plus AM equals AB. Well, what did we do? We substituted AM for MB because we said that they were equal, so I can substitute one in for the other. Okay. So what do we do to go from here to here? Well, what is? Well, we could say we just simplified, yes, because AM plus AM is 2AM. The textbook will say it's the distributive property. We did the distributive property backwards. Or we use the distributive property, but I will take simplified or distributive property. And last but not least, how can we go from 2AM equals AB to AM equals 1/2 AB? Property of equality, because what did we do to both sides? We divided by 2. Questions on this here? Any questions on any of this here so far? Why not? All right, guys. So we'll finish up with this tomorrow. And that's where we're going to stop for today.